right, so today we should have printed this interactive notebook page, cutting along the outer edge and then cutting to create these 3 sections. If you are unable to print or you've gotten to the point where your poor printer is just out of ink, you can recreate this page pretty easily. You should have read textbook pages 416 and 417. You didn't do that today, you did that yesterday. And we're going to go back now and revisit force, gravity, and friction. If you watched that video with that gentleman who did the experiment with the wooden blocks going down the ramp, I think he did a really great job of simplifying the difference between gravity, friction, and force. So let's take a look. Let's open up. We're going to go ahead and get started. So what do we want to know about the word force? What is it referring to? Well, we need to know that force is a push or a pull. So this can be a push or a pull. Give you guys a moment to get that written down. What we also want to know is that a force can change, whoops, I got ahead of myself there, can change an object's speed or direction. So in the video, he wasn't necessarily pushing or pulling on those wooden blocks. He was allowing gravity to move those wooden blocks. But we know that if he had used his hand at all and pushed or pulled the wooden blocks along the ramp, that would be an example of force. Zoom out. Let's talk now about gravity. We all know this word. We've heard this word since we were very young. We know that it's a force that keeps us grounded here on Earth. It keeps us sitting in our chair and not floating away. But how can we define gravity? Well, gravity is a force that pulls objects down to Earth. Gravity keeps you on the ground or seated in a chair. So then what is friction? Let's move this up a little bit here. In the video, he explained friction as a force that was basically acting against gravity, against those wooden blocks. So let's define friction as a force that acts directly against the direction of motion. Now, in his example, that would have been the car sliding down the ramp. So we know that gravity was acting against that. However, we know that the direction of motion would have been traveling down the ramp based on the direction of the ramp. We also need to know that friction can slow things down, or can even make them stop. So I'll give you guys a moment to get caught up. And then if you have your textbook handy, if you would, go ahead and grab that. I want to take a look at pages 416 and 417. When we're done, I'll bring this page back and I will show the entire page so that you guys can get caught up on these three definitions. So now I have my textbook here in front of me. And I can see these green arrows. So they gave us this example, right, in the snow, and they have a truck here, and we see the arrow pushing down, that this is showing gravity, which is pushing the truck down onto the road, and then force. They said that there's an engine, right, and then it will work to turn these wheels. So this is a force that's pushing the truck forward. Now, the friction is created right here, where the snow is actually pushing backwards against the truck, which is causing the truck to slow down. And the force of the truck, with the help of the engine, will continue pushing it forward. So they have this question here that you guys had to answer. Why do you think that workers would spread sand on an icy, snow-covered road? Those of you who have driven in snow or even driven on ice before may have experienced this. But those of us who have been here in Florida and not traveled up to an area where roads might be covered by snow or ice may be unfamiliar with this. So knowing, though, about force and friction, why might they spread sand on an icy, snow-covered road? Well, it helps with safety. But we want to recognize that the sand causes friction. That keeps cars from sliding off the road. Without it, there would be very little friction because of the ice or the snow, and they may just slide. Let's take a look down here at the bottom of the page. Let me move this. Oh, there we go. All right, so we have a young girl here, and she's on a sled. And we can see that, I know it's very hard to see here on this screen, but there's a rope that's tied right here. And it looks like maybe a dad or a friend, or maybe it's a wife and a husband, but it looks like he's pulling her on the sled. So we have to draw arrows and label them so that they are showing gravity, force, and friction. Well, we know that gravity is going to be pushing down on her, and that's keeping her seated on this sled and keeping the sled on the ground. Now, force is going to be created right here, this rope where he is pulling. So this is showing the force, which is moving her in a forward direction. And then friction is going to be right here. The snow is going to be pushing against her direction of motion. We would assume that she is traveling forward, so this direction, and friction is pushing in the opposite direction. Excellent work. Let me go back. I want to share with you guys this page just so you have a chance. You can make sure you have all three of these definitions recorded. So you can pause this video if you need to so that you can get everything caught up.